let's do example 2 with the law of sines. So I'm asked to solve a triangle. You'll notice this is the same triangle that I had drawn in example 1 because you can draw the triangle to scale, you cannot draw it to scale. It doesn't fundamentally matter all that much for the law of sines. So this is definitely not drawn to scale as my C is an obtuse angle. It's 130 degrees and all of these angles are very clearly acute. It doesn't really drastically affect me that it's not drawn to scale. The big piece of information I need to know is that angle C is opposite side C, and so on. So first thing I always do is list what I want and what I know, right? So I know that in order to solve this triangle, I'm going to need A, B, and C. I know that I know B, which is 16 degrees, and I know C, which is 130 degrees. I don't know little a, just like I didn't know big A. I do know little b, it's a 5, and I don't know little c. So again, the big hallmark that it is a law of sines problem is that you have a pair. So I look and I see that I have this pair, B and B. That tells me, hey, this is a law of sines problem, right? I'm able to use the law of sines because I have a pair. Now, the logical place to start, based on example 1, might be to start for little c because I already know big C, so I could find the missing part of the pair, and that's fine. But in this problem, you also have another option for how to start, which is that because instead of being given one angle and two sides in this problem, you were given two angles, we know that all of the angles in a triangle have to sum to 180, right? So these sum to 180 degrees. What that means is I can find the missing angle A pretty easily, and then I can use the law of sines to find both little a and also law of sines again to find little c. That's the option I'm going to take. So the first thing I'm going to notice is that A, right, big A, must be 180 degrees minus the sum of the other two angles, which is 146, right? So I'm pretty sure I get 34 degrees, right? So I get that A is 34 degrees. That's the first piece of information, and I didn't need law of sines yet. This also gives me a little bit more information. For instance, my big C is the biggest angle by far, so my little c should be the largest side. My big B is the smallest angle at 16 degrees, so that 5, that little b is 5, is going to be the smallest side. That kind of helps me, especially if I'm on a multiple choice problem where I might be able to eliminate some wrong answers. I'm looking for where big C, being the biggest angle, has the biggest matching side. If it were multiple choice, there's a solid chance that some of the answers won't have that option. So let's finish this out as though it's not multiple choice. Just one more reminder, like last time, make sure your calculator is in degree mode because otherwise tragedy happens. All right, if you're taking AP Calculus, your calculator should always be in radian mode on the AP Calculus exam. But chances are you're not taking AP Calculus right now, at least if you're watching this video. All right, so let's go ahead and find little a first. One of the cool things about this trick is I'm going to set up the exact same ratios to find little a and little c, so I can kind of do them at the same time. So when I'm asked to find little a, I know that the ratio I want to use is that a over sine of big A, which is 34 degrees, equals b, which is 5, over sine of b, which is 16 degrees. So when I multiply the sine over, I'm going to get that A is a 5 sine of 34 degrees divided by a sine of 16 degrees, which I'll type in my calculator. The cool thing here is I don't have to do all of that storing stuff because I don't need A to find little c, right? In order to find little c, I set up the exact same ratio, except instead of using A and the 34 degrees, I'm going to use this little c and the 130. So I'm going to follow my own work and say c over the sine of 130 degrees equals 5 over the sine of 16 degrees. If I multiply the sine of 130 over, I get c is 5 sine of 130 degrees divided by the sine of 16 degrees, which I can type in my calculator. Remember that it's not cheating if you can jump in your head to the step where you've written it like this. That's not cheating. Being able to skip steps is a totally natural, intuitive thing, but you have to find where your line is in terms of which steps you can skip and which ones you can't, because when you skip some steps, it's going to make you make simple mistakes. So if I type this in my calculator, I'm going to go ahead and type in the 5, right? So 5 sine of 34, right? 5 sine of 34. Close the parentheses, and I'm going to divide by a sine of 16. So it should look like this, right? And I hit enter. I'm already in degree mode from the last problem, and I get that my answer is 10.143 or 144. So my A is a 10.143 or 4, depending on if you round or truncate. Remember, either of those answers are right, but you should be prepared to give either, right? But I'm going to give both because I'm the teacher. Now, here's a fun little trick in case you didn't know this. If you want to redo this entry, but for C instead, in my calculator, I can hit second and then the enter button, which is at the bottom. Second and enter, and that recalls up the last thing I had. If you notice, the only thing that's different here is this sign of 130. I still have the 5. I still have the sign of some stuff, it's just different stuff. And on the bottom, I still have the sign of 16. So by hitting second enter, I can go ahead and go to where the 34 is and type a 1, 3 for the 130, but this is the tricky part. I'm gonna do second delete, which gets me insert, and type a 0. So what you'll notice there is I've now been able to enter exactly what I want. I hit enter and I get a 13.895 or 6. So when I type this in, I get a 13.895 or 6, again, depending if you round or truncate. So 13.895 or 6. Okay. Now, we should always do that quick mental double check that my biggest angle is opposite my biggest side. The 130 is the largest angle. The 13-point stuff is definitely the largest side. The 34 is my middle-sized angle, and sure enough, the 10-point stuff is in the middle. And then my small angle of 16 is opposite my small side of 5.